Welcome everybody. My name is Charlie Hallman. I am in the marketing department here at Deepwatch, and so excited to have you guys here today. Go over this Splunk Masterclass. We've got some great presenters here, and with that, I'll toss it over to them. So, Steven, take it away.
Thank you very much. Yes, welcome everybody to this presentation on how to get the best bang for your buck with Splunk, how to get that return on investment. And again, as Charlie mentioned, for the golfer enthusiasts out there, we appreciate you joining while the opening round of the Masters Championships are taking place. So again, we're here to help realize the full potential of Splunk. In many cases, shortcuts are taking and things are sped up in a way of which a lot of critical elements of getting that return on investment are skipped. So my name is Steven Leclerc. I am a principal platform SIM engineer here at Deepwatch. It's going to be 6 years coming up here in November. And I've had the fortunate ability to support all of our customers, specifically around Splunk engineering, and making sure that all of our customers are getting the best return on investment for their data. Mike, over to you.
Yep. I'm Mike Mizener. I'm the manager of our platform engineering team. My esteemed member of the team, Steven Leclerc. Let's be in full disclosure. I just want to say that this is Steven's presentation made by a guest appearance from me. I'd love to take credit for it, but there are witnesses and the HR as well. So, with that said, we'll be going over the agenda today. So what do we want to talk about is the Lean Team Challenge. So we're going to be touching on the overall challenges teams face with optimizing their ROI. Ingestion with intent. So what we're going to refer to here is purpose-driven log source onboarding, giving insight into your aligning data sources ingestion with your quote-unquote purpose. And then we're going to be talking about sending logs to the right tier. So routing data to the appropriate destination based on their intended use case or their need, and then improving detection quality as well. So we'll be, you've done your due diligence now with indexing your data to make sure it is quality data that you've ingested. And now we'll talk briefly on how to make sure your alerts are quality as well. And then we will button it up with a conclusion. So a shameless plug along with why we're here. So what does Deepwatch do? We provide 24/7 managed detection or response, MDR, continuously monitor across endpoints, networks, cloud environments using a combination of advanced technology with expert analysis. Deepwatch was founded on and launched by Splunk as our SIM offering as well. So just recently, we've branched out into other SIM offerings, but we have a very deep Splunk engineering team. Steven being one of those esteemed members, once again, of the team. And that's why we're here and talking with you today about some Splunk. So over to you, Steven.
Hey, all right. I want to jump in. Sorry, I want to jump in real quick. If anybody in the audience has a question, feel free to drop it in the Q&A box and we will answer them at the end. So anyway, off to you, Steven.
All right. Appreciate that. All right. The Lean Team Splunk Challenge. Do you feel the pain? I know I sometimes do. So what are some of the major challenges when, maybe you have a small security team of just 3 to 4 individuals just trying to keep that ship afloat with your Splunk environment, regardless if you're a Splunk Cloud customer or if you're a Splunk Enterprise customer. First and foremost is the complexity of your deployment. Maybe when you're first starting off, you've got a simple all-in-one instance. You got just a small license of maybe 20 to 30 gigabytes. But then as you mature, as you grow, things just get inherently more complex. You're adding additional forwarders. You're adding, if you're running Splunk Enterprise on-prem, you're adding additional indexers to your cluster to keep up with your ingest. Maybe you need to branch out, add in a search head cluster just to help drive the availability of your searches up. And so many more elements that add just, again, the multitude of complexities. So how do we tackle those challenges? How can we identify not only where to stand up and how complex to make it, but how to support it by your team? So on top of that deployment complexity, you've got your rising data volume. You've got data sources and tools everywhere, on-prem, cloud, hybrid. Maybe one data source has 4 different methods to ingest it. Is there a way that works better for your organization versus another organization? Probably. But which one's the best fit for you? And so hopefully by the end of this webinar, you'll have a better understanding of what could work for you and what could work for your organization. And lastly, just noisy alerts in general. Security specifically, they can get quite noisy. So how do you limit those false positives from the start? How do you increase the fidelity in your alerting? And ultimately, how can you give your team just a little bit of breathing room to investigate and triage those alerts? So first things first, before we can use the Splunk platform to run your detections and do some investigations, you got to do the GDI. You got to do the get your data in. But we want to do that with intent, right? And for that, I will toss it back over to Mike to talk a little bit about that.
Yeah. So thank you, Steven, for your detection goals. Before you onboard a new source, define the security questions it should be answering. So are you looking for credential abuse, privilege escalation, data exfil, lateral movement? So if the log source doesn't improve those use cases, it probably doesn't belong on the onboarding data onboarding to-do list. But if the boss says, for example, you need to ingest your VMware ESXi logs, that's great. We will do that. However, it is not going to be a priority because our use cases should be focused on security relevant data. So kind of segues into prioritizing high value logs is like, ingest identity, endpoint, firewall, auth, DNS, proxy logs, firewall logs, before the lesser value sources, because those feeds, those data sources are typically very high in detection content and as well as investigation workflows. So it keeps Splunk focused on the events most likely to produce some actionable security outcomes. So which data sources are most important to seek integrations first? That's everyone's favorite non-answer is it depends. If you have, look, for example, we're going to use that healthcare example there. So if you have a case of impossible travel, so a doctor signs in and a patient room, but however, they're across the complex at a different location of the hospital. And then you have a good example there of impossible travel. So focus on the security relevant data sources for that content. Over to you, Steven. Right as you take your
much. All right. Continuing on with our ingestion with intention. Some kind of key highlights on when you're going through your journey of not only just ingesting one data source, but trying to normalize it, trying to standardize it, trying to make it a repeatable process. And the name of the game on that is proceduralize it. Make a playbook. Identify some key points about the data source that you're trying to ingest. That's regardless of the vendor or product or method, etc. And some of those high-level things are: who is the source owner? Who are the stakeholders involved with that data source that you're looking to integrate with? What's the detection use case for that? Because that should be the first, again, that beginning question that Mike just asked is, okay, this is the use case. Let's make sure that we document it as to why this log source was ingested in the first place. And again, ingest method. Splunk is very well known for having a multitude of ways to integrate data sources. So documenting how you decided to integrate that data source will certainly help with maybe some further troubleshooting down the road, or maybe deciding on a format change or things of that nature. Very helpful. At the end of the day, you just want to make data source onboarding repeatable and auditable, because this discipline helps lean teams scale without creating a messy one-off logging habit. Configuration validation. So you've documented it, you crossed your T's, you've dotted your I's. Now let's look at all the supporting elements of that. And generally speaking, the first place you start at when you want to make sure that your data is coming in healthy is looking at any available technical add-ons, specifically from Splunk base. So if whatever data source you're looking to integrate, you're jumping into Splunk base, you find a TA for it, I highly recommend that it be downloaded and reviewed before implementation. Maybe that particular TA doesn't have the right, it's expecting a different format than what you're bringing in. Then there might need to be some changes instead of just relying on it. Cue the meme from the first slide. We don't want to be that clown to install that TA and all of a sudden realize it's not the right one. And part of the audit of that TA is most significantly the timestamp extraction and line breaking. Without these two elements identified and solved for, you're just going to have a bad time with your data in Splunk. Splunk is a time series based tool. And if Splunk is not extracting those timestamps correctly, searching for that data is going to be incredibly difficult, incredibly confusing, and just overall a bad experience. On top of that is your line breaking. If Splunk does not know where the end of one event ends and when the next one starts, you're just going to get garbage. And as they say, garbage in, garbage out. So part of this testing, something that we would recommend is using a test index with a small retention configured for it. That way you can keep your prospective testing integration separate from your production indexes and allow you to kind of fine tune those configurations to ensure that once you flip that switch over to production, you are ready to go. The data can be used, you can be implemented in those use cases, and you're off to greener pastures. Part of the health of that data is your common information model. If you are a Splunk administrator, or if you use Splunk, if you're running data model accelerations, if you're using anything around data models, the common information model is a well-known standard developed by Splunk that helps associate known fields and values with the relevant data sets. So if that TA that you're doing that audit, does it have all of that SIM normalization knowledge objects present? Are they there? Is it working as intended? Is the data that you just ingested in that test index, is it all there? Just a lot of those check boxes that we should be looking at before moving them over to production. And speaking of indexes, having a great naming convention can certainly help with a multitude of things. So by aligning your index names, right, with the type of data and or retention requirements, it should give you plenty of benefits, such as being able to just ease of search. So if you have somebody that maybe might not know SPL all too well, and you could just be like, hey, if you're looking for firewall logs, let's just type index is equal to firewall. So environment hygiene, definitely. Searchability, much easier. Data model acceleration, also a little bit more technical side, will really help with adding and increasing performance to your distributed environment, again, whether or not it be Splunk Cloud or Splunk Enterprise, to help ensure that your accelerated data models are running as intended and you are being as efficient as you can with the compute and the resources available. And here's just a quick dump of a recent TA I've created for a data source known as 5.9. During this procedure, I asked the customer to bring over some test events so I can start building out a TA for it. And of course, it always starts with those index time operations, right? So your line breaker, as denoted there in that top left-hand corner, your line breaker, basically telling Splunk where the end of one event is and the start of the next. Your time prefix, which helps with timestamp extraction performance. How far to look ahead in the event for that timestamp. In this particular case, 24 characters. And a few other items here. Scrolling down to the search time operations, a lot of these, again, are based around normalizing those events to the relevant data models from the common information model. So because we are denoting that this is JSON formatted data, generally speaking, Splunk plays very well with JSON data. So generally speaking, you can use field aliases first for things that are straightforward, but then with more complex situations, maybe you need to run some case statements, as you can see there from the eval action statement. You may have to add some additional complexities to ensure that your data is being parsed appropriately, and that ultimately the action field is quite significant, and you want to make sure that what's allowed is allowed and what's blocked is blocked, et cetera, so that you're making sure that you're getting the best, highest fidelity from your alerts. Over in the top right-hand corner, we have our event types and tags. Again, these are key elements of SIM normalization. So in the event types, we're just specifying the source type. And in this particular case, the header.event name where a login was attempted, we name that as 5.9 authentication, from which then in the bottom right-hand or middle right-hand corner are tags. That is where the tag is applied to the event and also allows it to conform to the data model itself. So now that we talked a little bit about ingestion with intention, we got the data coming in, but maybe now we need to make some small changes. Maybe we found that some data doesn't need to necessarily hit against our license, but maybe we want to keep it. At the end of the day, Splunk Enterprise or Splunk Cloud, above all else, is an analytics and correlation platform that is quite expensive. It's certainly not a log aggregation tool. It is not a tool of which you can say, hey, audits just came. We need to show proof that we have these logs. Can you take a screenshot of a search job at Splunk? Yeah, sure, that'll work. But I think there are a lot of better, more cost-effective solutions out there that can accomplish that same task. So jumping right into the tier aspect on how we can use our data and route our data more effectively. One of the bigger solutions that Splunk has released as of versions 9, enterprise versions 9 and 10, and as well as in Splunk Cloud, is ingest actions. So what is ingest actions? Well, it allows you to make decisions on your data wherever the data is interacted with by one or more Splunk Enterprise instances. Generally speaking, you can implement a regex or an eval statement that identifies and captures events and makes it a decision on them. The available decisions that ingest actions gives you is you can route your events to an S3 bucket, from which then you can either index later, or you can maybe, if audit's asking for proof of log retention, you can just use that S3 bucket. You could also use, if you're a Splunk Cloud customer, federated search for S3 to maybe to be able to search that. A second feature available with ingest actions is just going right to the file system. I haven't seen this used personally in the wild very much, but I could foresee a use case where maybe you have a file share mount on your system and you want to dump it to that mount. And lastly, nowhere. The good old null queue. This is great for just when you need to just drop data because you've determined and all of your stakeholders have decided that it's data not worth keeping. And in being able to use ingest actions effectively, regex 101 is going to be your best friend. Being able to debug, troubleshoot, learn different new tactics on how to make your regex more efficient, especially when you're dealing with, say, VPC flow logs or Palo Alto traffic logs. Something that's super high volume that you want, if you have any logic implemented to do some routing, that your regex is as efficient as possible. So you don't have to scale up and spend more money on your instances. A newer solution Splunk has developed is Edge Processor, what I like to call the quote new intermediate forwarding tier. So this is very similar to ingest actions with its purpose, but offered in a much more lightweight, scalable standalone service that also separates your control plane from your data plane. So now you can manage edge processor nodes, many edge processor nodes, from just one single location. Splunk offers this at no additional cost, and Regex 101 is still your friend. But because Edge Processor relies heavily on SPL2 pipelines, we added a QR code here just to help maybe get things started on how to learn SPL2. But it's generally speaking, I wouldn't say it's the same as SPL. There's some minor nuances. They've made it a little bit more friendly for those SQL database administrators out there that know the SQL language pretty well. But it certainly gives a lot more flexibility with what to do with your I shouldn't say that, how you can use your data, what you can do with it, and where you can send it. And here's just a quick overview of what was provided from Splunk on an example topology of where you could implement edge processors. It's very similar to ingest actions, but it's just a lightweight standalone instance that you can also put into clusters if need be, Kubernetes clusters, things of that nature. You send data in through the Splunk to Splunk protocol, HTTP event collector, syslog. You develop those pipelines, and again, you can either send it right off into your indexers or Splunk Cloud, maybe your remote object store, S3, etc. So moving on, we've got all that figured out, right? So everything that we've just talked about leads up to this moment. You've got your use cases defined. You've got your required data sources ingesting, and with the infrastructure in place to provide resiliency and redundancy. You've nailed down your timestamp extractions, your event breaking, and your metadata assignments, such as index, host, source type, etc. You got all the parsing in place for those events to be aligned with their relevant data models. So now you're ready to use that data. So what do we do now? Well, we want to start implementing our detections. But again, we're always chasing for perfection. And the perfection that is high fidelity alerts, only true positives. I've never really seen a situation where that's 100% the case, but we're always chasing it. So we want to chase that perfection. So part of that will be likely to tune that alert. Where are you going to tune it? Well, again, the age-old answer, it depends. Few places we can do this, and it's a very generalized approach. You can do it at search. You can do it before search, before the data gets parsed, or even at the data source itself. And maybe one question you could ask yourself when determining what solution's best for you is, how soon do you need those tuned logs available again? So let's start off with the first option of tuning at the search level. Maybe some reasonings for this is, your data is still valuable for other use cases. The data you're bringing in is super low volume, and it's just the juice isn't worth the squeeze to put in some technical control to limit that data being ingested to Splunk. Or you just need a temporary exclusion. Maybe you have some pen testing going on, but you want to just temporarily tune that alert out, from that. Or maybe you have an infrastructure alert and you know that it's 1 or 2 or 3 servers are going down for a maintenance window. So these are all great examples of where you don't necessarily want to cut off that data source, but you just want to exclude it from your logic. So some different methods that you could leverage is the raw, simple method of just updating the SPL within the search itself. It'll get the job done, but it's not necessarily a scalable way, especially if you have, say, a half dozen or even a dozen alerts that are using that same data source. So a more modular approach is setting up macros in your logic. So in this example here below in the savesearches.conf, we have an infrastructure alert that also implements a macro to exclude certain instances. And this macro is used across multiple infrastructure alerts so that we get the full coverage to ensure that for that time period, we will not be alerting on those specific hosts. And pivoting over to Mike to talk a little bit about the alert actions.
Yes. So, depending on the interval of your alert, once it fires, it will continue to fire until the matching criteria falls outside of that search window. And use the throttling alert action feature to suppress following alerts so that you don't blow up your queue. And then just keep in mind the configured time range should be longer than the interval of the underlying search for that alert. For example, we're using 24 hours in this in our screenshot here. So, no, we're not. Yeah, we are. Sorry. And then, so the query should be at or longer than 24 hours. Next slide, please, Steven. Thank you. So, staying on the topic of quality detections, archiving is a solution that is recently been a lot of conversations we've had with our customers about what to do with low quality data, low fidelity log events. So routing data to an S3 perhaps is at adjust time could be a good choice when you want to reduce Splunk licensing costs or you need that low value data just using only selected events out of that very verbose data source, whatever that may be. But you can also and then keep the selected events in Splunk, and then you could preserve raw or archived outside of Splunk for later retrieval or usage. So the different methods you could use that for is index actions and edge processors. So edge processor are both very much the same. They allow you to filter route data in real time before it's indexed. Edge processor is hosted at the network edge, though, and then ingest actions is packaged with Splunk Enterprise, Splunk Cloud, and is accessed through the So a couple different methods of approach there to keep in mind. What do you benefit from that? So you can get lower index volume, which can reduce ingestion, storage, and costs. Always at the top of Splunk's very high price tag for users, keeping that license usage low. Keeping Splunk to hold only a high value subset. So while S3 becomes the long-term archive of choice. So and you can still preserve an unfiltered copy for later hunting or compliance or reprocessing instead of permanently dropping the data altogether. So edge processor can perform transformations closer to the data source, which can be operationally cleaner than relying on lots of search time logic down the road. There are drawbacks, though, and something just to keep in mind is that data routed out of Splunk is no longer immediately searchable in the main platform, so investigations may be hampered or slowed or require federated search access to the S3, an S3 bucket. S3 also introduces extra operational pieces like bucket design, permissions, retention, lifecycle policies, and validation of the route itself. So Splunk has a warning out there that invalid S3 destinations can block queues and pipelines rather than simply dropping data. And then you lose some flexibility as well if you route too aggressively because data you didn't index is unavailable for ad hoc searches, alerting, and future use cases unless you deliberately keep or rehydrate them. And then the architecture itself, the architecture becomes more complex than simply tuning a safe search, especially if there are multiple teams that depend on the same type of events. Over to you, Steven.
Thank you. Come on. Work with me. There we go. All right. So we talked about tuning at search. We talked about tuning, tuning at the parsing level via archival. And now we're talking about tuning via the most destructive method possible, and that is dropping your data. Typical use cases for this is there's just absolutely no situation where you need this data, whether it either be an archive, whether it be in Splunk itself. You and your stakeholders have come into agreement that you need to no longer bring this data in or keep it. It's not valuable. Let's save some money. It's deemed to be just noise. So all stakeholders are in agreement. So how are some methods? And I will take a little bit more of a philosophical approach to this. It's generally speaking to tune as close to the data source as possible. Well, Steven, what does that mean? That means you want to free up your pipelines as best as you can and keep things, simple, by starting as close as you can to that data source. Now, functionality of that vendor and product may limit you from being able to do that. So I know, for example, that your checkpoints, you can implement certain filters at the checkpoint level to omit the forwarding of logs. Palo Alto, you've got your log forwarding profiles. You can add or remove from your firewall policy rules that instruct the firewall what to send over. So again, not all vendors and products have this functionality. If you're looking to drop some data on a specific vendor and product, you may need to look into the documentation to see if the data source itself is capable of doing that. So say, for example, if the data source cannot do any sort of filtering, it is just on or off. The next steps are kind of moving your way closer to the search level, right? So the next step is, where is that data getting sent to? Well, probably some sort of receiver, whether it be a universal forwarder, whether it be a heavy forwarder. For this particular use case, we'll call it a heavy forwarder. So at the heavy forwarder level, you will have bundled with us, provided that it's running Splunk 9 and newer, ingest actions. So you can implement some regex, some logic there to say, hey, let's just go ahead and drop it all together. Something we haven't really talked much about, but it's very much the classic method, is just creating your props and transforms. Props is the definition where you call a transform that says, hey, for this source type, go ahead and toss it over to this transform. Transform goes, hey, for data that's reaching this transform, match this regex. Go ahead, call the queue, drop it to the null queue. Ingest actions is essentially a GUIfied version of this, and they call them rule sets, but essentially it's the same operation that's occurring there. Just makes it a bit more user-friendly. So for benefits from dropping, obviously you're going to save some resources on all of your downstream data pipelines. No longer, say, for example, for your syslog collector, your UDP ports, if maybe those buffers were getting a bit full. And so by dropping them before it even hits that UDP port buffer, you're just helping to keep those pipelines free and clean. And obviously, the biggest benefit is reducing the license of your Splunk environment, as well as, again, kind of just the overall infrastructure pressure. Again, just helping to keep those pipelines clean. Obviously, the drawbacks, it's the most destructive approach. It doesn't really give you that many options. Say, if you need that data later on, again, unless that particular vendor and product has that functionality to go, oh yeah, you want that? We can set that up, or we can set up a batch input or something to retroactively bring that data back in. And so now I've got a quick video to show an example ingest action configuration. It's a silent video. I will do my best to narrate it. I did not practice this ahead of time, so we'll see how this goes. And I'll probably pause it along the way here and there. So in this particular example, we are looking at VPC flow logs. And we've identified a particular event or subset of events that we decided we want to tune or drop. So what I did there was highlight an event. I took the pieces of it, of source and destination, source port, destination port, and I added that into my filter to really get a sense of exactly what data I want to drop. So in this particular example, we're looking at 2 private IP addresses, which happen to be, in this case, our indexers. And we're looking at the port of 8080, whether it be source or destination, which in this particular case is our indexer replication traffic. So we have just come into an agreement that we don't want to log this anymore. VPC flow logs are generally noisy in general, as you can see. So we've got an agreement. Maybe we had to send this through CAB. Everybody's in approval that we don't need this data. So let's go ahead and drop it. So we ran this search to confirm. And come on, Steven. I know you're going to go to the right page. There we go. Moving on. So, as I said, regex 101 is your best friend. In the sake of time, I've already pre-populated the regex here for testing and validation to ensure that we want to match exactly what we want to match. Because one of the nightmares of tuning is developing improper regex, and all of a sudden you are dropping things that you didn't want to drop in the first place. So we took that regex, right? So now we're jumping over into ingest actions. And we're creating a new rule set. And in this particular example, we are doing this on the cluster manager, which has direct communication with the index cluster members. And because of this, we can actually preview using index data, because this particular instance has search capability to those search peers. So we filter the source type on VPC flow logs. I'm going a bit too quick, but let me pause it here. So we searched on the VPC flow logs. We pulled in our sample. We just pivoted over, took our regex. We're going to add a rule now that it will filter using that regex that we just developed. We're going to do it on the raw source fields, drop our regex in there, hit apply, and all of a sudden now we have our great UI of what will be dropped and what won't. And so in this particular example, as you can see, we are going to be saving 20%. And that's just from the event count itself. Now, from a size event, actually, you can also see that we'd be saving, so 20% of the size. So a pretty good chunk, because again, VPC flow logs quite noisy. So now, once we have confirmed we are dropping what we want to drop, just added in a quick description saying, hey, we're just going to drop indexer data replication port traffic. Maybe there is a change number, maybe there's a ticket number, something like that. Always good to reference that, so that when the next person, engineer, whoever steps back in, they're going to be like, why did this happen? Maybe I should go pivot into that case and see some more details there. Here, I mentioned a bit earlier, the old classic props and transforms of dropping events. So Splunk gives you the feature and the availability of being able to copy and paste these. If you don't, say, have the ability to deploy to an index cluster, you just want to copy these, go jump onto the command line of whichever Splunk Enterprise instance you want to set up this configuration on, and do it that way as well. But in this particular example, we are just going to hit save and hit deploy, because now it's going to be like, hey, we noticed you just did this. You want to deploy it to your search peers, your cluster peers? Yeah, absolutely. So there's our new rule set. Deployment was initiated. So in the back end, Splunk is doing a cluster bundle push. Here we are. We jumped over into the bundle actions. We got our 2 indexers there. We see the updated time was, at the time that I did this, just seconds from when I jumped over to that. And then lastly, for some of the final validation steps, I find this search for me is very helpful. And again, it's using the same regex here. We're just running a quick eval statement that says, hey, if you match this regex to the raw event, let's just flag it as tuned. Everything else, not tuned. And after it's been implemented, it's a great way of seeing just from an overall volume perspective. Okay, yeah, this makes sense. Like everything what I wanted to get dropped is being dropped. And everything that isn't is not. So yeah, it's a very, very helpful SPL for me personally to ensure that we are doing everything correctly. And unfortunately, because of you need some additional time for validation steps, I just added a quick screenshot afterwards to say here, after some time had passed, we can see that for the events that aren't matching that regex, it's business as usual. But for the items that we did want to drop, there we go. We just, at around 2:50, XPM, we started dropping those events. So in conclusion, I will throw it over to Mike to take us home.
Yep. So we'll put a bow on this with just highlighting what we talked about, what Steven talked about up to this point. So ingestion stage is the prioritization of important log sources. So define your strategy, define it early, get stakeholder buy-in. And this can't be emphasized enough. I can't tell you how important it is for our organization is create good, repeatable onboarding processes and document them. Yes, it's cumbersome. It's not fun, glamorous work, but it is absolutely necessary, and it will save your teams a lot of time and effort down the road. So then we're talking about sending data to the right place. Use the license you have wisely by keeping the noise out, keeping room for high priority data that aligns with your alert strategy. Be good stewards of your data. And then approving detection quality, no use cases or it's noisy, get stakeholder buy-in, a route to cheap long-term storage or drop it near the source. Remember when dropping data, start at the data source, work your way out. And if you can drop it at the data source, drop it, or if you can't drop it at the data source, drop it at the intermediate level using a heavy forwarder or leverage ingest processor at that point. So with that said, I think that will take us to the thank you slide. So thanks to everyone attending today. We appreciate you making room in your busy schedules to allow us to have this time with you. So now it's time for some Q&A. We'll be monitoring the chat. And if anybody has any questions, be sure and drop them in there.
Yeah.
If not, oh, sorry. Go ahead, Charlie.
No, I was going to say, yeah, if anybody has any questions, please drop them in the Q&A box. We did have one earlier that I know, Mike, you answered, but it might be good to circle back to it. So
yeah.
I'll read it out. It says, do you find that the TA will often have its own timestamp extraction and line breaking superior? And that's one question. And then the follow-up, superior to the defaults. Yeah.
Yep. So it was that was a great question by Joseph. So those TAs are developed with the particular data source or vendor in mind. So typically, yes, you will get better default extraction or extractions better than the default that Splunk offers because the TA is developed around that vendor or that data source. So we encourage very much using TAs and leveraging those as much as possible, keeping them current as well. So keep them on the latest version, and they can't steer you wrong. But it's always important, and Steven alluded this to earlier, is like trust but verify. That TA may be solid, but there could be a versioning change on the vendor side that changed the format of the data flow or the raw data logs themselves. So focus on just verifying that data. Trust that TA, but go back through and make sure and validate it. Make sure it's parsing properly. Otherwise, it's just going to cause bigger problems downstream. But great question, Joseph.
All right. If anybody has anything else, or if there's anything else you guys want to add, feel free to. Yeah, we're getting close to time, but we definitely have a couple more minutes if anybody wants to throw any questions in there. Or if there's anything you guys think about that you kind of get questioned on a good bit that might be helpful for our audience.
I'm not sure if I mentioned this, but and if I did, I'll mention it again, because it's something I always ask from when I'm working with a customer on integrating a data source is, hey, do you have just a small sample log or just something that maybe we can just run some validation steps even before we start ingesting it into that test index? Just a text file. And then, I've got Splunk running on my workstation locally just to go through it and test that TA out, see if it's doing the right thing. And if not, then that's the perfect opportunity to kind of add those local changes so that, again, it's helping you speed up those outcomes and getting to the point of where you can use that data faster.
Wonderful. Well, we don't have any more questions, unfortunately, and that's okay. But we can bring this webinar to a close. I want to thank Mike and Steven for their time today, and as well as everybody else that attended here today. And if you need these guys, you can reach out to them, either email. They're also on LinkedIn, so feel free to reach out to them. And with that, I will say happy Thursday, and everybody enjoy the rest of your week.